All right, so we've already kind of looked at these rules before and had a few examples that went through some of these. So let's just go ahead and do some more. So this is just a reminder of what the rules are, right? So the integral of e to the x is going to be e to the x. 1 over x is going to be natural log x, or natural log the absolute value of x, I should say. And then any exponential function, a to the x, integral is going to be a to the x over natural log of a. And then I don't know that we've actually done this one, if it's on your reference sheet or not. But the integral of natural log of x is x natural log of x minus x over plus c. And then we have one for just log functions as well. So log base a of x, the integral is going to be x over natural log a, and then times natural log of x minus 1, and then plus c. So let's just go through some using these. So I have to do u sub, right? So u would be 1 plus e to the x. So the du is just going to be e to the x dx. So my new integral is u to the 1/2 du. And then I can integrate that. That's 3/2 and then times 2/3. But then I want my original variable. So 2/3, 1 plus e to the x, and then 2 to the 3/2 plus c. Right? Can do another one. So u can try the exponent, 2x cubed. The du is going to be 6x squared dx. And I want 3x squared, so I can divide by 2. So 1/2 integral of e to the u du, which is just going to leave me as 1/2 e to the u plus c. And now I'll just put in the original. So we have 1/2 e to the 2x cubed plus c. I still have some word problems in there, right? So find the price demand equation for a particular brand of toothpaste in a supermarket chain when the demand is 50 tubes per week at 2.35 per tube, given that the marginal price demand function is as follows. If the supermarket chain sells 100 tubes per week, what price should it set? All right, so we actually just want to find the integral of that function. And then we're given an initial condition, right? P of 50 is 2.35. So let's do the integral. So I can pull this constant out. And then do u sub. So u can be that negative 0.01x. So that du is negative 0.01 dx. I can divide both sides by that. So that's 0.015 over that negative 0.01 and e to the u du, which will just give us e to the u. So 0.015, I'll get rid of those negatives. E to the negative 0.01x plus c. Then I want to find that, I have that initial condition, so I want to find what that's going to be, right? Is that a nice number? 0.015 divided by 0.01. Ooh, it's 1.5. So 1.5 e to the negative 0.01 times 50 plus c equals 2.35. So let's see what c is going to be. So negative 0.01 times 50 is negative 0.5. So e to the negative 0.5 is a number times 1.5 is another number. And then I want to take the 2.35 and subtract that number. And so I get c, let's just round it, 1.44. So then my function is 1.5 e to the negative 0.01x plus 1.44. And then I want to evaluate it at 100. So let's try that one. So negative 0.01 times 100 is just negative 1. So e to the negative 1 times 1.5 plus 1.44 is about, we'll round again, about 1.99. I guess really we could say 2. Either one is fine, but that's the price we should set given this scenario. Right, so that's kind of cool. Right, let's evaluate this one. So u is 1 minus x. So that du is negative 1 dx. So divide by negative 1. That's going to be e to the u du. And then we can throw our integral. So it's just going to be e to the u. And then I can put it back in its original and then evaluate it from 1 to 2. Or you can change the bounds and do it from this step here. I like the original. So negative e to the 1 minus 2 minus negative e to the 1 minus 1. So negative e to the negative 1 minus, and then e to the 0 is just 1, so minus negative 1. So negative e to the negative 1 plus 1. Do I want that actual number? Why not? So negative e to the negative 1 plus 1 is about, I guess I should put the equal, about negative 1.71. I don't know if I typed it in right. That doesn't seem right. Negative e to the negative 1 plus 1. Yeah, because that's not right. I typed in my calculator wrong. That's 0.63. Okay. Another word problem here. So suppose the rate of growth of bacteria in a petri dish is given by this function. If culture starts with 10,000 bacteria, find a function that gives the number of bacteria in the dish at any time, and then how much is in the dish after 2 hours. Okay, so that's going to be the integral of 3 to the t dt, which will give us what? 3 to the t over natural log of 3 plus c. It says we start off with 10,000, so our initial condition is 0, and then 10,000. So 3 to the 0 over natural log of 3 plus c equals 10,000. And we're in thousands of bacteria, so let's go ahead and just make that 10. So that's 1 over natural log of 3 plus c equals 10. And let's see, what is 10 minus that? 10 minus 1 divided by natural log of 3 is about 9.09. So our function is 3 to the t over natural log of 3 plus 9.09. And then we want after 2 hours. So 3 squared over natural log of 3 plus 9.09. And let's see what that gives us. So 9 divided by natural log of 3 plus 9.09. It's going to be 17.25, and this is in thousands. So 17,000, we'll say 250. Just round it like that. All right. Let's try this one. So let's say u is x to the 4th plus 3x squared. So that du is 4x cubed plus 6x dx. And I want 2x cubed plus 3x. So if I just divide all that by 2, we should be good. So 1/2 and the integral of 1 over u du, which will be 1/2 natural log absolute value of u. And I'll go back into our original. So 1/2 natural log absolute value of x to the 4th plus 3x squared plus c. All right, and then we have log 2x. So this is just the basic rule here. So we have x over natural log of 2 times natural log of x minus 1 plus c. All right, and that is all for some extra examples of log and exponential function integrals. So if you have any questions, let me know.